Hello again. This is Math 2232 coming to you from the College of DuPage. The title of this lecture is LSA1 Reflections, Summer 22. As always, please be attentive while watching this video. By way of introduction, we encountered some clear air turbulence, and this is the stabilization after that clear air turbulence. As some of you will recall, midweek, a Math 2232 student in one of the classes asked the LSA1 due date be moved to Friday. And in fairness, that meant, since it was almost Friday, moving it to June 24th, and not just for the class where the student asked about that or for the student, but for everyone in both Math 2232 classes. Inadvertently, this due date adjustment propagated to my linear algebra course for their LSA1, and there was a substantial confusion out there, and I'm calling that turbulence. So this note will establish stability after this unanticipated clear air turbulence. The solutions to this LSA1 for all three classes, Math 2245 and the two 2232s, are being posted, and the students will get credit for this regardless of what they've done. Going forward, the LSA content and due dates will be more clear and more stable as Jesse Hayes Carver mans these controls. But students will, for this LSA and all future LSAs, be responsible for understanding and learning from them. So let's move to the LSA1. And so LSA1 asks us to consider this function, y equals f of x equal the absolute value of 2/3 x cubed minus x squared minus 11 over 3x plus 2. I ask you to graph this function first of all, and again, you're not going to be using calculators, so you want to graph it without a calculator, and then you want to find the area of the region between this curve, the line x equals 0, and the line x equal 4. So let's look at the graph of y equal 2/3 x cubed minus x squared minus 11 over 3x plus 2. That's the blue curve that you see here. Now, one bit of pre-calculus that you have to use is you have to find out, well, what are the roots of this? And you can use theorems from your pre-calculus to come up with the rational roots. And it turns out there's rational roots, so you can find a rational root, and once you find one rational root, you can divide it into this to turn it into a quadratic and find the last two. So the expectation is that you can find roots such as this, and the roots of this function are -2, 1/2, and 3. That means it hits at -2, at 1/2, and 3. So that's the blue curve. But if we look at the negative of that curve, we get the red curve. Again, it hits the x-axis at the same points. But then I ask you to consider the absolute value, which means you always take it being positive. So you see the absolute value, since the blue curve is positive here, that will be it. But then we have to switch to the red curve to be positive. We come down, and then we go back on the blue curve. And then we are in the red curve again. So when we're looking at the graph of the absolute value, it's going to look like this. It's always bigger than or equal 0. And just another calculus note is it is not going to be differentiable where it has these abrupt changes in direction. But this is what you're going to be integrating, and you're integrating from x equals 0 to x equal 4, the area under between that curve and the line y equals 0. So that's what you're trying to find, but you see it changes definitions here, here, and here, so you have to compute 3 integrals. So the first integral, we go from 0 to 1/2. This is what we're integrating. And I think you can do this. This is a Calc 1 kind of problem. This is 49 over 96. But then from 1/2 to 3, you're integrating the negative of that function, and you get this value, 625 over 96. And then from 3 to 4, you're integrating the original function again, and this time you get 6. Now, students, you should be able to do these calculations, but that's what you do. But you have to add the three of them together. You add them together, and so the final answer here was 625 over 48. And the thing I showed you on the previous page, the graph of that, is the other part of the answer. So this is LSA 1. In closing, now more than ever, time is precious. Each day must count. Do the math, it'll make you strong. And now more than ever, take care of yourself, because self-care is important, and of each other, because we're all in this together. And keep your seatbelts fastened and tray tables stowed. God bless you all, and take care.